All right, let's jump right in. So, we are going to be talking about programs at Seattle colleges in science, technology, engineering, and math. I'm your host today. I'm Rachel Andre. I work for the Seattle College's district office. I'm the director of workforce development. And we are going to start off by doing some real brief introductions for our presenters today. So, let's start with Jeff. Would you like to do a brief introduction for us?
Yeah, of course. Hi, everyone. My name is Jeff Ang, he, him pronouns. I work at North Seattle College, specifically with students in our technology bachelor's programs. So at North, we have a BS in computer science as well as a BAS in application development. And then I
Thank
see
you, Jeff.
Jessica. Yeah.
Yeah, Dr. Jessica.
Hi, I am Jessica Pickle, and I'm a chemistry faculty at South Seattle College.
Thanks, Jessica. Meredith, you're up.
Hi, everyone. I'm Meredith Bain. I'm the outreach specialist for the electronics programs at North Seattle College.
Thanks, Meredith. Let's go over to Albert.
Hi there, I'm Albert Peacock, he, him. I teach engineering and I run a makerspace here at South.
Thanks, Albert. Reiner, you're up.
Hey everybody, my name is Rainer Heller. I'm one of the PACE faculty at Seattle Central. I'm teaching physics and engineering.
All right, Margot.
Hi, I'm Margot Ophelia, she, her. I'm the Technology Pathways Manager at North Seattle College, and I work with our networking and app dev students.
Thank you, Margot. Francois.
Hello, everyone. So I teach, like Rainer, at Seattle Central College. I teach engineering and physics.
Excellent. Thank you. And Ross.
Hey everyone, my name is Ross Vaswani Bai. I'm the program specialist for the Sustainable Building Science Technology Bachelor's Program that's offered at South Seattle College.
All right. Thank you, everyone. So today, you are going to get to hear about 5 minutes of presentations from each of these wonderful folks. And you can definitely feel free to throw your questions in the chat if you have any, or you can wait until the end. Once we get to about 5 o'clock, we're going back into the main room, and then you'll have an opportunity to join a breakout room individually with the folks in this room too here. So, for example, if you wanted to hear more about physics, you can jump in a breakout room to learn about that specifically. All right, so tonight we have a variety of programs here to talk, but we have about that's only about a third of the programs that we offer in this area of STEM. So you're going to hear from a lot of programs, but there's definitely lots more to learn if you're interested in exploring some of these other programs too. With that, we're going to go ahead and pass over to Jeff to talk about application development.
Thank you, Rachel. I think you can move to the next slide. So starting off with application development, our program is we offer a Bachelor's of Applied Science degree. Applied being the key word here. A lot of the program is focused on hands-on learning, less theory, more practical applications. So you're going to be doing a lot of group work projects. And other things about our program is that we do offer flexibility for our students. So students have the option of either completing the program full-time or part-time. A full-time track is 6 quarters versus part-time is 9 quarters. So that looks to be like 2 years versus 3 years. In terms of more flexibility, class format, we offer classes in a HyFlex modality. So students have the option of if they want to attend in person, virtually over Zoom, or 100% asynchronously online. We also admit students twice a year for fall quarter and winter quarter. And then in terms of class sizes, we offer very small class sizes. Maximum capacity is 28 students per class. And then in terms of prerequisites, there are some classes that you have to complete prior to admissions. So some of the prerequisites include 10 credits of programming, pre-calculus or statistics, a database class, as well as English 101. And students coming into the program, it's set up as a 2+2 program. So most students are coming in having either completed a prior associate's degree or bachelor's degree coming back from a career transition. And then we're located at North Seattle College. Some highlights, as I mentioned earlier, the program is really focused around practicum experience. So there's a lot of group work. So you're working with real life clients on real projects. So creating a product, so like a web application or mobile application, are there are a number of examples that we have on our website that I can share with you later on what students have created in the past. Other highlights include our faculty are very hands-on. It's very easy to, if you need to schedule appointments, meeting with faculty during office hours, or our faculty are very, very accessible. And that's in large part because of the small class sizes and the fact that our faculty, all they do is teach. They don't do research or anything like that. So it's really great. We have wonderful faculty in our programs. And then in terms of jobs, we have a number of folks who have been able to find jobs in the tech area. So in terms of careers, you can collect new skills with either a capstone project or an internship. So in terms of internship, we do offer support if you are interested. We have Steve Balo and John Lee, who are our technical employment specialists, who work with students if you're interested in finding a job or an internship. Potential job titles once you graduate, those include software developer, software development engineer, software engineer, machine learning engineer, etc. And we've had folks being able to find jobs all over the Seattle metro area, including Amazon, Slalom, Microsoft, Expedia, Google, Disney, Starbucks, Salesforce, T-Mobile, all over, big and small. Moving on to our other program, we do offer a BS in computer science. So next slide. And our BS in computer science is a bit newer. And it does offer two options as well. You can either complete the program on a full-time track, which is 6 quarters, or a part-time track, 9 quarters. In terms of class format, this particular program does require in-person attendance. I forgot to mention earlier that all of our classes, application development and CS, they're all taught in the evening, all evening times. So it's 6 to 8:40 p.m. And then in terms of start quarter, we only admit students into this program for fall quarter. And then in terms of class sizes, it's the same, 28 students is the cap. And then prerequisites are a little different. There are 3 programming classes, CSE 110, 142, and 143, which covers Python and Java. And then for math, there's pre-calculus and statistics are required, as well as English 101. And it's also located at North. Some highlights. Our program was jump-started through generous funds from Amazon, as well as, so we have a really close relationship with them. And in terms of some highlights about the program around AI, that is a pretty big thing in the industry. So in terms of what we're doing as a program, we're incorporating more and more AI skills into the classroom, since that's going to be really important for graduates of our program. So we're continuing to develop that in our curriculum. And then we do offer 2 tracks in our program, a data science track, if you're interested in more like AI, machine learning, data analytics, things like that, as well as a general CS track. Careers, similar as before, you can either do a capstone project or an internship. And then same with the job titles are very similar, but this program a bit more focused on folks might getting like software engineer type of roles.
All right, thank you so much, Jeff. And Margot, you're next.
Hi, everyone. Forgive my voice if I'm a little shaky, but I'm Margot Ophelia. I'm the Technology Pathways Manager here at North, and I help advise for the networking and application development programs. Next slide. So we offer a wide variety of different certificate and associate's programs in IT, ranging from 2 quarters all the way up to 6 quarters. so about 1 year to 2 years. We have options in cybersecurity, application development, and network and server administration. Many of the courses are offered online, and we also have in-person options, and we are building out new labs so that if you need and want in-person and hands-on experiences, we have those available for you. These programs have rolling admissions, so you can join either the fall, the winter, or the spring or summer. There's not a hard limit, and we try to individualize the experience for our students so that we can get everyone through. Our class sizes aren't too large. They range from about 20 to 30 students max. It is not a cohort program, so it can vary depending on the class. For placement, it's mainly just English 101 and into Math 98. If you place into a higher math, that's also awesome. We are happy to welcome you, and we can also build you up. Our location is at North Seattle College, along with the bachelor's program that you just saw from Jeff. Next slide. So some highlights are you learn to apply scientific or technical knowledge in order to understand issues, solve problems, engage in useful and responsible practices in computer programming and also networking. We try to prepare, well, we do prepare, and we also provide discounts for students who are pursuing CompTIA networking and security certifications, as well as the A+ hardware certification, so that we can try to get students as competitive as possible when they enter the job market. We want to prepare you as best as possible. We teach you how to install, configure, test network devices, servers, workstations, and as I said before, we're building out physical labs so you can also work on these in person so that you know how these things work, so that when you get to the technical interviews, we can prepare you to succeed. And you can specialize in fields like cloud, cybersecurity, CIS administration, and software development are two main tracks for network and server administration, and then also application development, which leads to our bachelor's programs that you just heard about from Jeff. An additional highlight is that we just revamped our curriculum with our industry folks so that if you're learning up-to-date industry relevant skills so that you can actually go and get a job. It's not old curriculum. We literally are on the phone with them all the time going, okay, what do we need to help our students succeed? And we implement that and involve that. So you are learning really up-to-date skills. Next slide. For careers, we prepare students for a variety of roles. For app development students, a lot of our students go on to the bachelor's programs here at North. And apologies. We prepare students for full stack development, data engineering, QA analyst, being a QA analyst, software engineer, and more for our network and server administration roles. Primarily, these are in network administration, IT specialist, and also help desk or SOC analyst for our security folks. We do work with the bachelor's program as well, the employment team with Steve and John, so that we run, I think, resume workshops, LinkedIn, interview prep, so that we can prepare you for those actual job interviews and how to actually land a job. A lot of our alumni work at places like Microsoft, Port of Seattle, EA, Transaction Network Services, DocuSign, etc. And a lot of our students come back as alumni to help us with events. I know for our bachelor's level events for North Tech Talks, we run pretty large meetup groups that attract a lot of folk that talk about how to land a job. What do you do when you actually get an offer? How do you negotiate your pay and benefits and things like that? and what are the skills that you need to learn to best succeed. And I think that's about it for this page. Thank you so much.
Thanks so much, Marco. All right, Jessica, you are up.
Hi, I'm Dr. Jessica Pickle, and I am teaching in chemistry at South Seattle College. Want to go into the next slide? So, our program offers an Associate of Science, and it takes 6 quarters full time or up to 9 to get through the program and prepares students to go on and transfer to a bachelor program and then as a jumping off point into a career or into post-secondary or graduate's work. Our classes are in person and online. Actually, all of our classes have a hybrid modality. So you will be doing in-person work, but also have online work to do as well. And our introductory course is offered fall, winter, and spring, though most of our students that are on this track will go either starting in the fall or the winter. Our class sizes are small. They are at just 24 students. And so our lab space is not overcrowded, and students can get a lot of attention as they learn to work with different instruments. Now, to start at the introductory chemistry level, you need to place into Math 141 and have taken a Gen Chem prep course, Chemistry 139, or test out of it. And our program, or the program that I'm at, is at South Seattle College, but chemistry departments are also at North and Central offering the same program. Next slide. Thanks. So when you are in our program, you get to practice laboratory techniques with different types of scientific instruments, and that allows you to explore the chemical concepts that you are learning in class. And so we have a lot of inquiry in our experiments and our activities, and that way we can try to break apart and really understand complex chemical problems. We also will analyze and interpret chemical data from a variety of different sources of instruments. So that way students can start to just identify patterns of how matter behaves while also getting experience with the tools chemists use to better understand the world. Next slide. Thanks. And as someone who's going through and getting an AS in chemistry, most of our students are using that as a stepping stone into a different bachelor's degree in chemistry or in a related field. Environmental scientists and specialists come out of our program, and some students also take this into a biochemistry career pathway or material science, which ties into engineering and chemical engineering. Some of our students use this as a jumping off point to become food scientists and technologists, or study the atmospheric science or be an atmospheric and space scientist. And then we also have students that take this as a point to go into even computer and information research or like data science as well. And our students have been able to get internships at places like the Fred Hutch and the EPA, and a number of our former alumni are now graduate students at the University of Washington in the chemistry department, and making progress towards their master's and their doctorates. Thank you.
Thank you, Jessica. Meredith.
Hi, everyone. I'm Meredith Bain. I'm the outreach specialist for the electronics programs. Today, I'm here to talk about two of our programs, the electronics technology and electronics engineering technology programs. These programs are a great fit for you if you like to learn by doing. If you're someone that likes to take things apart to figure out what's wrong with it and then put it back together, it's a really great fit. In both programs, you will gain broad foundational knowledge in electronics, and we really emphasize hands-on learning. So you will have classroom time and then lab right after. You can kind of choose your option here. So one option is the electronics technology AAS degree, and that's designed for folks that want to go right into the workplace once you graduate. The other option is the electronics engineering technology transfer option. So that's for someone that maybe you're thinking you want to do additional schooling It's a limited transfer option. So right now it only transfers to Central Washington University. And that would be if you were interested in pursuing like a Bachelor of Science in Electronics Engineering. The difference between the two is that the transfer option, you're going to be required to complete the calculus and physics series of classes. You will take physics and math in the associate's degree. It's just not the series of calculus and physics that you might need to do. With our program, you can start any quarter. So you could start spring, summer, fall, winter. If you want to attend full time, you'll complete the program in about 8 quarters. You can take the program part-time though as well. Many of our students are working and going to school at the same time, so they do part-time classes while they're working. And it really just depends on what works best for you. You get to choose. This is my schedule this quarter, so these are the classes that might work best with your schedule. To get started in the electronics program, you need to place into Math 84 or higher and English 98 or higher. Since the focus is on really hands-on learning, the classes are all offered in person. Some of the highlights of our program, our instructors create a supportive learning environment and really encourage you to ask questions. You will take a broad range of classes like circuits, fiber optics, IT essentials, hydraulics. This will be that foundation so you can really get ready to get to a career. All of the classes have classroom time, and then immediately you're going to have the opportunity to practice these skills in the lab. We have 6 different electronic labs. The main electronic lab, where you'll kind of begin with those foundational courses, is set up to resemble a workbench. So exactly what you might find in the workplace. You would have a workbench with some common testing equipment, and you will gain experience really hands-on learning and training on that equipment. In those labs, you would work as part of a team to complete your lab work. Part of your team is your instructor. Your instructor's in there with you in your class and your lab. All the labs are done with your instructor support and really allow you to learn these new skills in a safe environment. Our faculty have a variety of industry experience. One of our faculty actually graduated from our programs, and they really know the skills that employers are looking for in electronics technician. We are continuously connecting with local employers to share job opportunities with our students and graduates. And we can probably go to the next slide. And so our students, they get jobs as some kind of technician role. It kind of depends on the company that you land at, what it might be called. It could be calibration, it could be electronics, it might be instrumentation, robotics, field service. Really, the common thing is that it's some kind of technician across all industries. They work in a variety of companies, and you can see some of them listed there, but Amazon, Boeing, Blue Origin, Crane, Stryker, Astronics. Our students graduate and get land jobs pretty quickly in the area. And the whole program is built so that you would land a job right after graduation. Thank you for your time today.
Thanks, Meredith. Albert.
Hi there, I'm Albert Peacock. I'm here to talk about engineering at South. So we offer an Associate of Science. This is a transfer degree. Most of our students do complete in somewhere between 6 and 9 quarters. It really kind of depends on where their math level is. If you're coming in at Math 98 level, it's going to take you a little bit longer. We have some additional classes to help support your professional growth. So you're learning applicable engineering skills. We've got a new CAD course that's real exciting. But if you're coming in at a calculus level, you'll probably finish it in 6 quarters. That's a 2-year program. Most of our classes for engineering now are face-to-face, but we still have a lot of hybrid courses that are going to be your other prereq classes like physics and some other like math and science courses that come along with our curriculum. Our average class size at South is pretty small. We're running classes that are somewhere between 10 and 16 students. So you have a lot of face time with me and our other instructor. To place into our engineering classes, like I said, if you're going to do the 9 quarters, you can really come in at Math 98 level and then placement into English 101 class. I'm going to talk specifically at South because we also have some of my colleagues here from Central, but there's also a similar engineering program at North. So highlights of our engineering program at South. The big thing is that you get to learn how to quantitatively model and look at complex problems, which is the problem solving skills that are applicable across lots of different industries. I have lots of my colleagues that graduated with civil engineering degrees that work in finance. So it's a program, skills that are really applicable across a ton of different industries. At South, we put a lot of focus on being able to do active learning and then also really apply these skills hands-on. For a theory-based engineering class, that's a really, really powerful thing. We also, at South, we have a makerspace, so and that's incorporated into a lot of our classes. So if you want to learn some design skills, we can 3D print, we can laser cut, and we can do some electronics if you want to build your skills and learn by doing. It's a really great way to kind of extend your skills outside of the classroom. We got a bunch of different careers for engineering. Civil engineering is my favorite. That's my background. But civil engineering, there's many job titles for civil and environmental engineers, including environmental engineering and also structural engineering. Anybody that's designing buildings and bridges, that's going to be structural engineering. That's under civil major. There's lots of different industries that civil and environmental engineers work in, including environmental engineering, road design, drainage, waste and water treatment, and then like all the buildings that you spend every day in. A lot of those were designed by a structural engineer. The median wage for this is a little bit low because a lot of folks that work in civil and environmental engineering, these are smaller firms, so a lot of these people become owners of the companies. So this wage is a little bit lower because there's a lot more smaller firms that people work for themselves, and then they don't show up as civil engineers anymore. They are now owners, partners. Next slide. We also have a lot of mechanical engineers. I would say a good portion of my students, probably about 50% of them, are seeking to get a mechanical engineering degree to go work at Boeing or many of the other aviation type engineering opportunities that exist here in Seattle area. But there's also a lot of other mechanical engineering opportunities. It's one of the most diverse in terms of like industries. They show up in HVAC, all the things that keep us comfortable in the buildings that we live in. There are people that design all the controls that control the devices around you. And then also the vehicles. Those are all, industries that are run by primarily mechanical engineers. Next slide. We also have some electrical engineering opportunities. If you're interested in that, we have all the classes that you need to get a transfer degree and then pursue a 4-year degree in electrical engineering. This is a little bit different than technician. This is going to be more design-based instead of building stuff yourself. So it's kind of cool. You kind of explore both of these opportunities in the Seattle Colleges district. They work on circuits on all different sizes, power systems for buildings, whole power grids that power our entire nation, how we generate that power. We also have, folks that are going into designing controls and then working with the mechanical engineering partners and building robots and manufacturing. A big part of manufacturing now is designing the robots that do that work.
All right. Thank you, Albert. And now we're going to move over to Reiner to talk a little bit more about engineering.
Yeah, hi everybody. And you can, so I'm working at Seattle Central, and we can go to the next slide already. So a lot of the information that I have was already presented by Albert, so I'm just going to summarize it again. You will likely end up with an Associate of Science degree. There's a couple of different ones. Which one you would go for depends on your engineering major. So you have to kind of make a decision. Do I want to go into industrial engineering, electrical, chemical engineering? And that determines which Associate of Science degree you would aim for. The duration, like how long are you going to be with us? Albert already said it. It really depends on where you currently are. So if you start at a Math 98, then it likely will take 3 years. If you already are ready for Math 151, which is calculus, then you can get through in 6 quarters. And it also depends on which major you go to. So there are some majors like mechanical, civil, aeronautical engineering that have quite a bit of coursework required for transfer. And then there are other majors, electrical, computer engineering, where the number of prerequisite courses are the list is a little shorter. So you technically can get through the 2-year college level a little faster. You can start any quarter. Class size, same as at South. We are typically running physics classes at 25, and then engineering classes anywhere from 20 to 30. So capacity is 30. And compare that if you take the same classes at, let's say, the UW, you'd be looking at, I don't know, 150 students. So you get much more of our attention. We take you aside when you struggle and ask you to come to office hour to practice with us. So that's a strong argument for us. Next slide. Hang on. Oh yeah. So I don't have this broken up into different majors. So we have the engineering, the pre-engineering courses for all the various majors. So there's a picture here of a circuits board. So we teach a circuits class that's required for mechanical, electrical, and other majors. Below, you can see a little balsa wood bridge. This would be an example of something you would be designing, building, testing in our statics course. So we have a series of several courses that you would take, typically as a mechanical engineer, as a civil engineer, industrial engineer, aeronautical engineer, and others. So depending on your major, you would then be in these classes. Next slide. And so I listed as possible jobs, basically your engineering majors. There are many more than I listed here. The big ones, again, electrical, mechanical, industrial, civil, but you can become a chemical, you can become, it's a list of about 50 different engineering majors. We are doing the first 2 years, just like South, and then you would finish your degree at your 4-year transfer institution. Similar for which industries do our students end up in. I listed just a few here, but anywhere. I think I included, I didn't include City of Shoreline. I just recently had an engineer who works as a civil engineer on the light rail system that we are now expanding, and he was doing a road project in Shoreline. So our students end up all over the place. And I think that was it. Yeah. Thank you.
Yes, thank you. Francois.
My mic was off, sorry. So hello, everyone. So I'm going to talk about physics. Actually, in the order of things, physics would come before engineering in your course of studies. So we can go on with the next slide. So physics is required for many of the majors that you would select in the sciences. Could be chemistry, biology, earth sciences, environmental science, engineering, of course. You could have also a major in physics. Typically in physics, we offer two series. One which is algebra based, which is going to be for students who would select more a biology track. For instance, if you're a pre-med student, you would take these classes. If you're more toward the engineering track, you would take the calculus-based physics. How long would that take? Well, it says here 6 to 9 quarters. And as was said for the engineering case, it depends on where you place at the beginning. So if you have already a good level in math, you can do it in 2 quarters. If not, you might need more. In 2 years, I meant. If not, you might need more. The classes that we offer are hybrid. Meaning that you will meet at school. So all of our classes have face-to-face meetings, but not all of the credits are taught in the classroom, except maybe for a few exceptions. But most of our classes are hybrid, meaning that you're going to have some work to do online as well. You can start any quarter except possibly maybe in the summer, though if you were kind of short on your math curriculum, it would be maybe a good idea to start in the summer. I would say that still the bulk of our students taking physics classes come in the fall. It's maybe the best quarter, but it can be started any quarter of the year. Our classes are like for the engineering classes are smaller than at UW. I would say significantly smaller. We have a capacity at Central, it says 25, it's actually 24. It's because our lab space for safety reason, it's a directive of the fire marshal. We can have only 24 students in our lab space. So it means that you can have good attention from your instructor as you're studying. And as Rainer was saying, if you struggle, we are there to help you. And I'm talking about Seattle Central College, but similar programs, of course, are available at North and at South. We can go on to the next slide. So what are the highlights of our program? So we try to focus on the hands-on experiments. So meaning you're going to have lots of teaching done in the lab in the form of experiments or tutorials. And this is going to be done for the 3 quarters of physics if you were to take them all. So whether it is mechanics, electricity and magnetism, or waves and optics, you will do lots of experiments because we think that active learning, doing it with your hands, is a key to learn well physics. So you won't be listening to lectures all of the time by far. So we try to have you be active. We can go to the next slide. So you would take physics classes as a stepping stone to a 4-year program at some other university. For instance, many of our students are transferring to the UW, where you would go into some engineering program or biology program or physics program. And after having completed these 4 years, then careers are available to you. And we've talked to some of our former students, and this is where they ended for some of them. It's listed here. For instance, we have some students who went to Boeing, Microsoft, SpaceX, the car industry. Actually, it's not listed here, but 1 or 2 of our students were working for Tesla. So really, it's a full range, and only big names are listed here, but our students are also working for smaller companies. So this was to present the physics program. Thank you.
Thank you, Francois. Okay, Ross, you're up. And Ross, you're going to be the last presenter tonight.
All right. Hi, everyone. My name is Ross Aswani Bai, he, him, and I'm the program specialist for the Sustainable Building Science Technology program offered here at South Seattle College. So we are a Bachelor of Applied Science degree, a BAS degree. A couple things to note, to graduate, students are required to have 180 credits. This includes previous education or associate's degree or any credits that you might be transferring in. The SBST program itself is a 90 credit program. 60 of those 90 credits are what we call core classes. So those are your SBST core classes. And then the additional 30 general education distribution requirements like your math, communications, English, arts, sciences, fill those remaining 30 gen eds. It takes typically students who are full-time 6 quarters to complete the program. We only offer classes, the SPST program only offers classes in the fall, winter, spring. And so as a full-time student, you will finish in about 2 years. We do have some part-time students, as we are also understanding that things happen to people, or things happen in our lives, and sometimes we need to adjust plans. So we work with students to come up with an education plan that makes sense and fits their lifestyle. We are in person, and or I'd say we are mostly a hybrid program. We meet 4 Saturdays each quarter. Those are in-person meetings, and they're usually full-day Saturdays from 8:30 to about 5, where you rotate through all your SPST classes. And those Saturdays are about every 2 to 3 weeks. They're not consecutive weekends. We kind of spread them out throughout the quarter. We do have Wednesday night interviews with industry experts, so there's a chance to network with people who are in the field. Those Wednesday nights are recorded, so if you're not able to attend online, then you can watch them on your own time. And then we also do have weekly online assignments, readings, and quizzes that are due each week using our online learning platform. We typically start in the fall. We are a cohort-based model, so our students start in the fall, and then they carry out through the program with their cohort, moving from quarter to quarter. We do have some alternative start dates, but we prefer students to join the cohorts in the fall. Class size, we're a relatively smaller program, which gives you a lot of high touch or high points with your advisors, myself, and program staff and faculty. Our average class size is about 10 to 20 students. Prerequisites, students must have an associate's degree or within 25 credits of an associate's degree to be accepted into the program. And it's not a requirement, but it does help students in their first year, especially their first year, if they have some work experience in the built environment or understanding of building operations and building science. But again, that's not a prerequisite. That's just something that will help you as you move through the quarters or through the program itself. And we are part of the South Seattle College. We are located at the Georgetown campus. That's where our classes are held, and it's what we also call our living lab. As most of our assignments and labs are working in the buildings, on top of the buildings, using the spaces learning environment, as well as also real world application, as the college itself is in need of compliance and energy and operation management plans that our program supports. Next slide, please. So some highlights. We do focus on technical skills. So there's kind of like 3 pillars. There's the technical skills, which are the applied learning, hands-on learning, really developing a foundation in building science and understanding the operations of buildings and the science and technology that goes into these places that we live, work, and play. All students after that first quarter do receive a certificate in building science, building science foundation. The second pillar is our fiscal management, where our students are learning through their curriculum and our professional network what it's like to work in multi-million-dollar capital management capital projects, mostly in infrastructure, facility management, these large building projects. It's also important to note that we're not a construction program or an architecture program. We are looking mostly at the environment that is already in existence, the built environment, and how we can support those existing built environment to decarbonize, to become more energy efficient. Another part of that pillar is the professional communications, and I want to highlight this one because this is probably one of the most important skill sets that our SPST alumni know, is that the ability to explain or to communicate the technical skills, or why it costs so much to invest in this technology to various stakeholders, is something that's really important as you're working through different projects or in different places. That communication skills are really important. And then the last pillar is the sustainability pillar, where our curriculum really supports the learning in energy auditing and analysis. Policy is a big part of our program and curriculum. Understanding looking at different forms of energy efficiency and renewable energy. All in all, just looking at how we can support a healthier, more durable efficient, sustainable built environment. All of our students, another highlight I will point out is that all of our students do complete 900 hours of work experience, and most of that is accomplished through internships and work experience practicum. So there's a number of internships that we work with our partners to support students in identifying career pathways and support their own professional goals. But a lot of those internships are in designing buildings that are at the intersection of sustainability and human health, addressing climate change, energy infrastructure solution, decarbonization to net zero, both in the residential and commercial sectors. The last note I'll point out here is that, and starting new this year, that our students are supporting the Pacific Northwest Building Training and Assessment Center, which is a grant that was awarded in partnership with the University of Washington and the Northwest Indian College, where our students, SPST students, are able to be hired, and it's paid positions where they're supporting the technical assistance and resources for building assessments to again meet the net zero emissions targets. And there's two gaps really that this grant is, or the BTAC program is trying to accomplish, and those are the gaps are to train a workforce and access to benchmarking and strategic roadmaps for energy efficiency and decarbonization, especially in disadvantaged communities. And also students will complete, upon completion of the BTAC program, they'll receive a certificate that can be used towards their professional development. Next slide. Careers, there's a number of careers that students can go into. I won't spend a lot of time here, but there is a lot of pathways moving forward. And I will note that a lot of green jobs, quote unquote, green job skills that our students are developing through the program are really valued in non-green jobs as well. We're finding more and more that green jobs are necessary for all types of jobs. And the last thing I'll note here is just that there is a projected increase in job growth, but there's a gap or a gap in the skilled workforce that will be needed to place or to fill those jobs. So there's lots of opportunities for our graduates. And I believe that's all I have. Thank you.
Yes, thank you. And thank you to all of our presenters today. We are going to switch gears and move right into Q&A here in this room. So please feel free to come off mute to ask a question or put a question in the chat. We'd love to hear from you and learn kind of what you're interested in and what you learned today. So please feel free to ask some questions now. We have about 15 minutes to do that.